Hi, welcome everyone. Happy to have everyone on this call. And we basically would be starting from where we dropped off yesterday. And today's class would start by doing a little review of what we've done from previous class, as that's our normal usuals. So let's just have your hands up if you're willing, as usual, to share some of what you've enjoyed from last class that you can remember. Yeah, Stephanie, please.
Good afternoon, Ayo.
Good afternoon.
So in our last class, we spoke about custom data type, and you said we had two types of custom data type, the enum and struct. But we only spoke about the enum. Then enum is used to create variants, and we have two types. We have the result, and so we use the result when you're expecting an error. So example now, when you don't know what the user is going to pass in. So you don't know if the user is going to pass in the right data type or whether the user is going to pass the wrong data type, and you want to handle the error that is going to come out. So you use the result type. Then for the option is when you are trying to get a data that does not exist, then use the option.
Excellent.
Um, yes. The example you gave is all this a divide function where 10 divided by 0 obviously throw an error. So you are using it to particularize the result. And then for the option, uh, I've forgotten the example you used, but that is all
I
I
used
have
the
to say.
same example actually. I used the same example, but this time I returned a null instead of a result. So thank you so much, Stephanie. That literally is an overview of what we did yesterday. So I gave an assignment yesterday. I don't know. I see your hands up if you are able to solve the assignment, just like a hands up. Yeah, Stephanie. Who else? Shaliga, did you try it? Jani, Jojo, Julius, Miriam, Miracle, Maru. Did any of you try the assignment from yesterday's class? Nobody tried it apart from Stephanie. Okay. Okay. Um, One thing I always say is, yeah, you can put your hands down, Stephanie. Great job. One thing I always say it's how important it is to, always try your best to implement or re-implement what has been taught in class. And assignments, doing it to literally strengthen your strengths in this journey of learning this programming language. Like I said, this programming language we're learning, Rust, it's not the same language as other languages that you know of. It's the learning curve is a little steep, and the best way for you to gain this knowledge so well is to learn it well. Without much ado, we'll be moving on to what we have today, and that would be talking about the second data type, structs. Now, what is a struct? So I'm going to do everything in our code editor, but let me comment this out. And so we are good to go with something new, basically. So comment every single one of it out. Okay, we have this. So we are going to create a new main function, and yeah, we're going to start afresh. So today we'll be talking about structs. What are structs exactly? Structs is a kind of data type that allows you to combine different data types together. You can basically say it allows you to group data together into one. What do I mean by this? You literally define struct by using the keyword struct. And let's say you want to create a struct of users. You can create a struct by doing this and say struct user. It would have an element string, name, it's a name. It could have age, an I32. What do you think a user could also have? It could have probably um, the sex, that's gender. So it could be male or female. So we could use char for it. So that would be either F or M. That's male or female. Then is married. We could want to check the marital status of the user. We could ask, is he married? Then we use a bool for it. So if it's married, true. If not, false. Then what else can we think of a user? Um, let's also check, is the user alive? Okay. What other thing can we think of the user? We could also think of the user's profession. Profession. Good. So let's stop there. So this basically is a data type that is used to group data together. In this case, we notice that we literally have different data types. We have string, we have I32, we have character, we have Boolean, another Boolean, we have string. So this particular data type, we can use it to group a person or different datas. It doesn't necessarily have to be a person. Now, in this case, I'm using users. As time goes on, we are going to see how I'm going to change all of this. And I'm going to, in fact, use it for something different. So it doesn't necessarily have to be a person or a user. It could be a data that you're just trying to group for different personalities. So in this case, how do you then use a struct? How do you consume a struct? So let's go to our main. We could say let person one equals user. Inside of it, we will then create name, and there we would say the person name is Ayo, Ayomide. Then the next thing we'll be taking in is the age. Let's say Ayo is 12 years old. Then the sex, we could say Ayo is a female. Then is married, we could say false. Okay, is alive, we could say false. Then next, profession, we could say um, is a farmer. And basically, now, why do we have an error? Let's see. User has no field profession. So let's change this to profession. So in this case, we have created a person with all of this data. The user has a name, he has an age, he has a sex, he has the data type if he's married or if he's alive. We have his profession. Okay, we have a chat. Julius. Okay, Julius. Let me see. Oh, let me see the attendance. Okay, so Julius has been promoted to a panelist. Okay, let's get back to what we are working on. Okay, so now for this kind of data, we've grouped this data for one person. We can use the same struct, literally, person two, and say user is name. This time, we're going to say the user is Bola. And then the next thing is age. We want to say Bola is 72 years old. Sex. We could say Bola is a male and is married. We could say true. Is alive. We could say false. Hmm. How come everybody is dead? Let's make this one true. Then profession. Uh, Now I'm going to show us something from this error coming up. Let's say, what profession is a teacher? Good. Now notice something I did here. I spelled profession different from how I spelled it here. And now I have a compiler error. What's the compiler error telling me? It's telling me that this particular user field is not part of what is here. So that means when you are defining everything you are defining here, it's important, always important, that you do what? That you ensure it is the same spelling or it is the same user field. So if we bring this one and we change this to what we spelled there as professions, then the compiler error goes. Now notice that it's the same from this user struct that we've generated data for two different individuals. In this case, we created a group of data for just one entity. And then we created another group of data for a different entity. So you can think of struct as a way to just create group data and reuse this group data, basically. Now, what are some of the characteristics of the struct? Now, notice that we mentioned that each of the field elements of this struct must have the same exact one as the original one coming from the struct. That's one. Another one is, it doesn't really matter where all of these things stay. You could choose to start with the profession. You could choose to put the age on the list or the last thing when you are declaring or using up the struct. It doesn't matter. What matters is that at every time, you must always make use of every single field in the struct. So in this particular case, the field we removed is age. So for that reason, we would have a compiler error because it's missing a structure field, age. And so we need to uncomment the age. So from what we've just made mention, it doesn't matter where the field elements find themselves. All that matters is that every one of it is there. What are some uses of structs? Now, like I've made mention of, the major use of structs is to group a data together. But then, is there a way for us to programmatically create these structs without us having to, you know, try to write all of these fields over and over and over and over again? Yes, there is. How do we know this? Okay, so we are going to do something. We're going to create a random function. Now, I'm going to take us to explaining another feature called implement. And this implement, you are going to see it very well when we have started talking about Soroban. Because in fact, most of what you'll be seeing in Soroban has to do with struct, implementing it with the methods. So I'm going to go deep dive into explaining all of this very well. In fact, very, very well. So let's start by creating a random function. Imagine me typing function out like it's JavaScript. So this function, we are going to name it create user. And inside of it, we have name, which is a string, right? We also have age. Age is I32. We have the sex. The sex is I32. No, the sex is chat. It's a character. Is married. Is married. It's a Boolean. Is alive. It's also a Boolean. The profession. The profession is a string. And so let's say we are returning a user. Wow, this is so long. You know what? I'm going to reduce my screen a little bit so we can see everything. So can we see it here? In fact, let me bring this down so we don't have to read. Let me increase my screen back. So good. So what I just did was I did cargo FMT. It's literally used to format in Rust. So once you want to format your code, you use cargo FMT. So that's what I did. So in this case, with this function, create users, I was able to do something. So I'm going to create user, and then I can add name, I can add age, I can add sex, I can add is married, I can add is alive, and I can add profession. So what have I done here? I've created a function that programmatically creates the struct for me. So I don't really have to, you know, do all of this. Having to create the user struct and do, all I need to do is, I'll just say let person3 equals what? Create user. And then I will just basically add everything I need to add to it. The name string from, let's say, Miracle, and the age, let's say Miracle is 43 years old. The sex, let's say Miracle is a male, is married, true, is alive, true, professional, profession, let's say an artist. And let's make it to string, basically. So with this, we've created this person. We've created this person, and all we want to do there is for us to do what? For us to call this function, and basically it has created this user. So you can imagine this and this, which one would you prefer? To create it programmatically or not? Now let's go back to our function that we created. Now, our function that we created here, notice that I was not putting in front of it name and age like I would have done normally, or I should have done, or sex, or it's married. I didn't do all of this, and everything still worked fine. Why? This is because the parameters coming in for this particular function is the same as the field elements in this struct. And for that reason, when the parameter is the same, there's really no need for you to do all of this. Really no need. But let's look for a scenario whereby we change one of the parameters. For example, we change this one to underscore sex. What happens? We have a problem. Let me remove this and we see. Now we can no longer use it directly like that. Now we have to, in fact, do what? Make it standard. So we have to add this in front of it, basically. But for others that has the same spelling, there is really no need for us to do that. So you can create um your struct like this, basically, and then you can consume your struct like this, and everybody goes home happy. So before I move on, is there anybody that has a question based on what I've just explained on struct before I move on to explaining how to implement a struct and how to use the struct? Anyone? Any question? Okay, Cecilia. Oh, Celia, please.
Okay. Yeah. Thank you, Ayomide. Can you hear me?
Yeah, I can.
Okay. So, w- I'm not familiar. I'm not really familiar with Rust, but I'm familiar with Cairo a bit, and it looks like it was built off of Rust, right? And looking at the struct right now, um, I'm just applying my knowledge from JavaScript. It looks like JavaScript objects, if I'm not wrong.
You are not wrong. But it's deeper than JavaScript object because you would be seeing some beautiful things we can do with structs. But please continue.
Okay. So for the create user you just did, right? You already defined the struct below, and I saw that you use the same, like you define the types, and that's what you're using to create a person, right? Where you call the user and then give the values of the person in there. But then for the create user, I'm a bit confused.
Okay. What part are you confused?
Okay, so I didn't see it down. Okay, so that means you already created it. You already created a function for it,
Yeah,
where in inline you can call the create user and then just put in all your values,
exactly.
right?
Exactly.
Okay,
Exactly.
okay. I think it's fine then.
Yes. 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 So, okay, I guess someone also have a question. Uh, Maru.
Hello.
I.
So the function is basically like a constructor function in other languages.
Yes, but it's not what it is. It's just, you can think of it as an ordinary function. What we are going to do as we proceed is I'm going to explain to you how to do that. In fact, that's what we are moving on to now. I just wanted everyone to be clear that for a struct, you can basically come over and create any function you like for the struct just to, initialize your variable. But can we do it better? Is there a much better way for us to do it? Well, that's what we'll be proceeding to. But that makes sense. I like the fact that you were able to think of it from that angle. You can think of it like an initializer. Yes, a constructor. Yeah, that's very correct. So, does anyone have any other question before we proceed? Yeah, Mary, please.
Also, she said like the structs are somehow similar to JavaScript objects,
Yes.
but can we uh, put methods to them like we do in JavaScript?
Yes, we can. And that's where we are getting at.
Okay, thanks.
Yeah. Yeah. So now we've made mention of the struct, and we made mention that we can just create an initializer with a function. This is an ordinary function, and we can create an initializer with this function. We've also looked at the fact that it doesn't matter where any of this appears. We also looked at the fact that if the name from the parameter is the same thing as the field element of the struct, then there is really no problem at all, based on what we can see here. But then if the field element is different from the parameter, can you see, you have to define it like this. So we've come to the agreement of that. Now let's comment all of this out. Oh, before we comment it out, I think I forgot to tell us about something. So while I was working here, I created this. This is a derived debug macro. What this derived debug macro allows us to do is it basically allows us to print our struct to the console, that is, to our terminal. So what it does is that if I remove it, watch, if I remove it, and you see, let's try to print any of these. Person one, let's say person one is, and I try to print this person one. I try to print this person one. In fact, let me try to add something like this in front of it and all of that. Can we see the error we have? We have this compiler error. User doesn't implement debug. So the trait debug is not implemented for user. That is pointing out to what? To this struct. So for us to print this particular struct out, that is, after creating an instance of the struct, for us to print it out, we have to add this derived debug macro. And so this trait will basically allow us to do what? To print it to the console. So with this, we can basically print person one, and if we clear the console, the terminal, and we cargo run, we should have it. Can we see? The person user one is name, age, and every other thing. We can basically print it. That allows us to what? To print it. Another way for us to, we can literally also have access to each of the variants of whatever we are printing is by using the dot notation. What do I mean by this? We could say person one name is, we have this, and he is this years old. And so I can say person one dot name and person one dot age. And with this, we are good to go. So if I can go run this, let's clear this, and I can go run it. Can we see? Person one name is Ayomide and he is 12 years old. So he has basically destructured all of the data from here. So first of all, you can now say, let person one name equals what? Person one dot name. Now, we have a problem here. Can someone tell me why we have a compiler error here? Based on what we have been teaching in our class, can someone tell me why we have a compiler error here the moment I typed person one name equals person one dot name? Can someone tell me? Yeah, Miracle, please. You can unmute, Miracle. Oh, sorry, I have not added you today. Okay. Yeah, you can unmute, please.
Okay. So the reason why there's an error is because of referencing, right? So another variable is referencing the value.
Sorry, can you speak up? I'm barely trying to hear you. Or is it just my network?
Hello, can you hear me?
Okay, now this is better.
Okay, I said the reason why there is an error is because of referencing, right? So another variable is referencing the value, and that variable has not been used or has not been called. So that's why we're having this error.
Thank you. Thank you. Now, I love the fact that you actually understood the concept. You understood what was going on here. And that's because it actually has to do with ownership. But then, this case, the answer to that question is that this new variable has taken up the ownership of person1.name. So this name here is a string, and I have passed the ownership to this particular variable. So instead of this struct, everything is occupied, but this one is not, because it has already been moved to someone else. And that's why if I try to access it here, I have a problem. I have a what? I have a problem. Why? Borrow of moved value. The value has been moved into a new variable called person1_name. And that's the problem there. Can we see? So thank you so much. So one thing I could do here is I could either borrow it, or I could do something interesting. I could clone it. Now, I'm sure this is not a new concept to us because I have basically explained ownership, reference, and even cloning. So I could do any of these two to avoid this problem, basically. So that is literally how you have access to all the elements or the fields of this structure. Yeah, Maro, please. You can unmute and speak, please.
So we're declaring a variable which isn't a string, like for example, the age.
Yes.
Will it bring the same error?
Good question. So let me ask someone from the class, what would happen? Will it bring an error? Can anyone answer Maro's question? Miracle, please.
Okay. Before I answer, can the question be asked again? Like, can you iterate over the question? Like, can you come?
The question is, in this case, we are having this error because we are trying to use a moved value. And in this case, the moved value data type is a string. Yeah, it is. It's a string. And now we are trying to move it. We've moved it into this place. And let's say we don't have this clone there of the borrow. We would have this problem because we're trying to, use a value that has already been moved to a new variable. But then his question is, what if the value is not a string? The value is an integer, a signed integer, like for this
Like,
example, the
if
data type for age. What would happen? Would we still have an error?
like if the person underscore one does make an integer, right?
I'm listening, please. Your voice is kind of low.
Okay, I'm trying to, like, is it asking if person underscore name, person underscore one?
Am I the only one struggling to hear him? Maru, can you hear him?
Not
No,
really.
I can't.
Oh,
Hello,
miracle.
can you hear me now?
Okay, this is better.
Okay, I'm asking, right? I'm asking the question: is it if the person underscore one dot name is an integer, will the problem still exist? Is that the question?
The question is, if the data type is not a string,
think. Yeah, but it's
What
another thing that
happens?
it will still give the same error.
Hmm. Thank you for your answer. So your answer is it would still give the same error. Does everyone support him? Is everyone in support of what he said? Sila?
No.
Okay, thank you, Mario. No. What of Sila?
Okay, so I'm not really understanding the question, but for me, if the variable has moved and
Yeah.
you're trying to call it with its name, like the dot notation, using its name, right? It's no longer there, so there's going to be an error, like what happened? So if it has a different data type and it's still a variable, if it has moved, of course it won't show up. So that's what I think.
Hmm. I haven't heard Stephanie's voice. Thank you so much for your reply and your answer. I haven't heard Stephanie's voice. Stephanie, you want to say something? Stephanie? Hello?
Oh, my network went.
Oh,
Network went. I did not believe that. Can you hear me?
okay, I can hear you now.
Can you hear me?
Yes.
I said my network went. It's low.
The question is, if now, for this instance, we have a moved value because it's a string, and we are trying to reuse it here, so it's giving us a compiler error. The question is, if we have the same situation for age, which is a different data type, that is what? That is an integer. Would we have the same situation? Would we have the same compiler error situation as a string? Julius, please.
I think the answer is no, because we kind of say the numbers implement the copy trait on themselves.
Great,
So for integers, it won't.
great. Thank you for that answer too. Thank you for that answer. Now, let's try it. Let the code give the answer to us itself. Now, in this case, we'd be using, let's change this one to person one, age, and then let's change this to dot age. Now, do we have a problem? The answer is no. This is because the problem happens when we are talking about a dynamic sized data type. So there's a difference between the dynamic size data type and a static size data type. Now, in this kind of data type, we already know the size of this data type. And that is why in memory, it is literally on the stack, not on the heap. So what is happening here is that for the string, which is a dynamically sized data type, it is on the heap. And so there is a pointer like a mapping to the data in memory on the heap. So when we say that this value is no longer owned by it, means the pointer has been moved to this variable. This variable is a new one pointing to that value on the heap in memory. So that means this does no longer have, we can no longer have access to it from person one because it's no longer able to map it in the memory. So that's what we are trying to say. But for this data type that is a static type data type, it is what? It is on the stack because we already know the fixed size of this data. We know that this data, I32, the size of it is what? Is 2 raised to power, where is it? 2 raised to power 32 minus 1. And because it's an I32 and the size is coming from both the negative and the positive side of the number line, so this is divided by 2. Half of it is on the negative, half of it is on the positive, basically. And that's why Another reason it doesn't have a copy trait because you're not trying to copy the old data into another storage location on the heap like you would do for a string. So thank you so much, everyone, for the answers you've given. Okay, Sila, your hand is raised up.
Okay, so that doesn't mean that we'll have to understand algorithms and also pointers.
Oh, well, the truth is that Rust is almost close to a low-level programming language. And that's why mechanisms like ownership, reference, it's one of the superpowers of Rust, and you have to understand it, basically. And so you trying to understand it means that you need to understand the heap, the stack, and how memory literally works, basically. But not you do not have to kill yourself so much on it. Let's hear from Stephanie.
Sorry, please, can you like you have I did not understand.
Sorry, I didn't hear what you said. Hello? Hello, Stephanie? Can someone hear Stephanie? Okay, let's hear Miracle.
Okay. So I just wanted to confirm. So the ownership stuff, right, is different for the way it behaves is different for static data types and dynamic.
Yes, yes.
So for dynamic, like the string, I think the tuples and the arrays, they are dynamic as well, right?
No,
They're static. Static.
they're static, but they are just a compound data type.
Oh. So the only dynamic data type we have is vector and strings.
Yes, for now. As we
Oh,
move on, you'll be seeing other data type.
okay.
Another
So
one, again, is what? Is the struct. Is the struct. Let me try to do something. In fact, let me use it to ask a question. Let's try to do something here. Let's try to say, let's do it here. In fact, we don't need these remaining persons. We really don't need them. So let's just comment them out. Really don't need them. Let's just work with person one. So let's name this new person one. New person one. Yeah. And we say new person one is equal to person one. In this case, what exactly happens here? If I try to print person one itself, and I try to print person one, are we going to have a compiler error or not? I've not saved it. So I want to just know, are we going to have a compiler error or not, Miracle? Oh, I left there, so I saved it already. We are having a compiler error. It already gave the answer because it automatically saved. We are having a compiler error. Why are we having a compiler error? I don't know if I'm the only one struggling to hear Miracle.
okay. I said maybe struct is dynamic, so that's why it's having issues.
Exactly. It's Stephanie. You can unmute and speak, please. Your answer up, Stephanie. You can unmute and speak. Okay. The answer is that. Now, let's be logical. The truth is that we are able to say that this is a static typed data type. Let's go back to all of this. No. All of these data types, let's copy it and let's bring it back home here. Let's bring it here. Or do this. Let's bring it back here. And I would uncomment this. The fact is that we are able to know this size of this data type. We already know it. We already know the size of this data type. We already know the size of this data type. The same thing as this, we can calculate it. We already know that this is a string slice, it cannot expand. So we know the size, we can count it and calculate the size of this data type. But this string, we don't know the size because at the end of the day, you see this string one, you can do dot push. And inside of it, you can add a. We're having a problem. Why? It is an immutable. Sorry, let's make it mutable. So you can add and push. You can even push this. Let me remove this and change it to this. Give me a second. So if you want to do this, you have to push a character. I was trying to push a word. So you have to push a character. So what I'm trying to say is that you can just basically keep pushing new what? New characters to add to this string. Unlike a string slice where you cannot even have access to what? Access to adding more variables to it. So you can keep concatenating more and pushing more variables to it, just like you would do to a vector. You can keep doing that basically, right? But then for other data types, we already know that they have a fixed size. Now, why are we saying this? Or why did we go back to this? Look at this struct user. For the struct user, we don't know all the data sizes in this struct user. Why? Because we know that this string can expand. This one too can expand. Imagine we now have another variable called what should we call it? Um um Awards. Let's name it awards. Awards. And now award is a vector. And so why do we have this problem? Oh, I've not added it here. I've not added it here. Let's add it here. Award. Let's say award is a vec I32. So let me remove this. So, oh, this is awards. Let's change it to awards. Yeah. So where are we having the error from? Oh, this one. Let's remove this one. Since we no longer, that means we have to create another field awards for this. Let's remove this one. Okay. So now let's go back to our code here. At this particular point, we have added a vector too. So that means we don't even know the size as to which this vector can increase to. So this particular one has no size, and that's why it is also dynamically sized. So it's a grouping of data that we don't even know their size. For that reason, when you move it, the ownership is also moved to another person, literally to another variable. So just like the vector, like the string works, this also works in the same manner. So did we get that? Now, we spent so much of our time talking about ownership on strings and on structs without actually getting to the major part of our class today, also due to the fact that the class started late. That doesn't mean we are not going to do what we are meant to do today, because this week we want to ensure we are done with all the basics of Rust. So what are we going to do? In what instances is even struct important, or why are we even learning about struct? Is it just to group our data? Well, we are going to look at an important part of Rust, which is the implementation in Rust. So for this, I'm going to create an example. So let's say we have an example that says, create two functions that calculate the area and perimeter of a rectangle. So now, normally, what is the way we are going to do this? We can basically create a function area, and inside of it, area will take the length, which would be an I-32, or in fact, we can make it a floating point, an F64, and width would be what? An F64, and then we would return an F64 basically, and we multiply length times breadth, and everyone goes home happy. Oh, I used width instead of breadth. Okay, so now we move on. We create the next function. We have perimeter, and the perimeter also have length F64, and it has the width F64, and it returns an F64. And then for perimeter, you know, perimeter is 2 into bracket. Okay, let me just add the multiplication. 2 into bracket length plus width, right? If I'm correct. Why do we, can someone tell me why we have an error, a compiler error, please, quickly? Can someone tell me why we have a compiler error here? Let's see how well we can identify errors. Anyone? Yeah, Miracle, please.
So, from my own experience, right, and knowledge, I think the reason why we have the error is because of the data type. The length and the width is a floating point. Y2 is an integer, so it doesn't usually work.
Excellent answer. So we have to do put 2.0, or we can say as F64, anyone basically. But this is an overkill. Just put 2.0 and you're fine. So with this, we can basically create, we've answered our question here. And so every time we can always come here and create an area. We can say let area equals area. And then we add our length 3.4 and width 4.2. And everybody goes home happy. The same thing could happen to even the perimeter. And we do perimeter and calculate it, and the same thing. Let's say we have the same value we are trying to calculate for the perimeter. We can print these values and we go home happy. The area and the perimeter, we can go run it. Everything will be fine. Clear. Can go run. Everything will be fine basically, right? You see, the area is 14.28 perimeter. Now, if we want to do the same thing over and over, we have to keep calling these methods like this and passing in the value or having to create it. What if we use a struct to solve this problem? What if we do it in a cleaner method whereby everything can be created, an instance of this rectangle can be created? We know that if you are calculating the area and perimeter of the same rectangle, the length and the breadth will always be the same thing. So why don't we use a struct to undo this? So for this, we can use a struct for it. How do we use a struct? We use a struct by using the implement. How do we do that? First of all, we can create the struct and we can name the struct rectangle. So inside of this rectangle, we would have our length, which would have it as an F64. Then we would have our breadth too, which is going to be an F64 basically. So how do we then use this rectangle? We use it by using this implement keyword, and then we would use rectangle for it. And inside of it, we can now create what we call a constructor, just like what? just like someone made mention of earlier, an initializer. So first of all, we would create that initializer. We would name it new. So for new, we want to have the length, F64, and the width, F64 too. And this time, we could return a rectangle. We could also return something different called self. Now, what is self? Self is literally the instance of this rectangle itself. So you could return either self or rectangle. In this case, you could also say rectangle is length, is the length, the width is the width, and everyone goes home happy. Naturally, you could have just used return and you add this at the back, and yeah, that works too. But I just want a cleaner code, so I'm just going to leave it like this. So now with this, we have an instance of this rectangle. This rectangle, you could also use self for it because this self represents the instance of this what? Of this rectangle. So next, we're going to create another method. This time, the method we are going to create, we are going to name it area. So this area, what are we going to do? We are going to have just one parameter, and that parameter, we are going to call it self. And then the parameter is going to return an F64. And what are we going to do? We are going to say self.length times self.width. And then we are going to return an F64. Notice that I am borrowing this self by creating a reference of self and then using that reference here to return a value, F64. So now we are also going to create our perimeter. So let's see, perimeter. And for this, I'm going to say self, and it's also going to return an F64. And inside of it, we're going to say 2.0 times self.length dot self.width. And so with this, we've created a simple application that does what? That creates a new instance of a rectangle, and we can basically perform different actions like the area, the perimeter. You can think of other things you want to add to this, and it will basically do it. So for example, let's say we want to try out a new function. I hope this is not commented. Okay, let's try to see where the main ends. Okay, sorry, this is where it ends. Okay, so let's try to see it. How do we create the instance of the new rectangle? We could say let rec1, let's name it rec1 equals rectangle column new. And we have 3.4 and we have 4.2. So this is rectangle 1. So we've literally created instance of rectangle 1 using this new. Now, don't get, you can call it anything. You can call it initialize. Like I said, you can call it anything. But usually in Rust, the initializers is usually called new. So let's just follow the protocol. So we'd call it new. And so we've created an instance of this rectangle. And the instance have a length and a width. So let's create or calculate the area, rec1 area. So all we have to do is to say rec1 dot area, and it's going to calculate the area for us. Now, we could also say let's rec1 perimeter should also be rec1 dot perimeter. And it would also calculate the perimeter for us using these methods that has been created for this rectangle. So with that, we can basically print our stuff. So we can start by saying print the area, and the perimeter is what? Rec1 area and rec1 perimeter. And with that, we could cargo run. Let's clear this first and cargo run. And yeah, we have it here. The area is 14.28 and the perimeter is 15.2. So this could go as complicated as it can be. Now, the example we did before for user name, age, sex, and all of that, you could even create a bank account with this. You can go on to create different examples with this. You can go on to create a user profile. You can use this. This is, in fact, the building block for building applications in Rust. So if you understand structs very well, you understand how to implement a struct, you can keep adding so much methods to it, and your application would literally keep growing, basically. So this could go on to be so complicated as possible. Even here, we could also add even the derive debug macro here, and we can print out this itself, that the area, the values, that's the length and the breadth of the Rust of the rectangle itself, can basically go on to do that. So at this point, we've spoken about how to implement a struct. So are there any questions from anybody at this point based on what we've implemented and done? Yeah, Miracle, please.
Please, I just want to see the code base. Your code.
Yeah, here is the code.
Okay. The where they were implement the where they
Yeah.
were called the rec1.
Okay, this is
Rec1.
what I called them. Now,
Yeah.
notice I didn't have to add in parameters like I was doing for those functions that I created. All I just needed to do was to what? Dot area. Because I'm already getting the length and the breadth from where? From here itself. Can you see? So you can go on to build on sophisticated applications using this. It's left to you how you are, what you're implementing it. So this is how we come to the end of our class for today. And everyone, your assignment again for your practice would be using structs, build an account software, a simple program that has a struct field of account, name of account, and you can basically create methods for all of these. You create borrow, withdraw, deposit. So basically, I want everyone to do this assignment as it will help everyone to understand the Rust programming language better when you're talking about structs. So at this point, I'll stop recording. I'll stop sharing my screen first and I'll stop recording.